Hello, Mr. Ryan, are you right?
Yeah.
Okay, so we have what's binary tree?
Well,
5, let's say 5, 6, 1. Is it a binary tree?
yes.
Okay. Is this a binary tree?
No.
Okay. It doesn't have cycles, yeah? It doesn't have cycles, yeah. What's DAG, by the way? Remember we talked about this?
Directional cycle.
Directive acyclic graph. Okay, so look, if I have this 1 to 2 and 2 to 3, it has direction, but it doesn't form cycle. And how about this? If I point it here, does it have cycles? 1 to 2.
Yes.
Yeah, it has cycles. So we talk about the binary tree. So how many subtrees are there? How many subtrees are there? Which subtree?
Oh, there are 3.
What are those?
6, 5, 1. No.
6?
6, 1, 5, 6, 1.
5, 6, 1. Yeah. What's the average? How do we calculate average?
Well, you just plus all of the numbers in there and then.
Okay,
divide
sum
how many
divided by
numbers are
count.
there in.
Okay, well done. So in order to calculate the average, we want to calculate the sum and the count. What's the average of this one? This subtree?
6.
What's the average of this one?
1.
What's this?
4.
How do you get the 4?
5 plus 6 plus 1 divided by 3.
Well done. Okay, good job. Given the binary tree, we want to find out the maximum subtree average. We want to know this maximum subtree average. Which is which one? Which one? Come on. Which value is it? What's this? How? 4, yeah? Which one is bigger?
6.
Yeah, so we find out that. Got it? Okay, so do you still remember how we calculate the sum of the sum? First of all, we want to know the sum of the subtree or tree, yeah, binary tree. Binary tree, yeah, binary tree. We use the recursion, remember? Depth first search, root. And first of all, we need to, for the recursion, usually we need to check the base cases. If root is none or not root, or you can write it as not root, right? Return, what's the sum of it? What's the
0?
Zero.
Nothing.
Zero.
0, 0, 0.
If I want to return 2 numbers, what kind of data structure can you use in Python? What kind of data structure?
Depth of search.
No. The data structure we want to return. This is return a single value. We call it singular. How about we want to return 2 numbers, 3 numbers, even more? What's the
3 is a forest.
What's the data structure we're going to use to store 2 numbers, for example? What kind of data structure can you propose to store 2 numbers?
DQ.
You can use the DQ or the simplest one. I mean, or you can use the notebook, but I'm talking about storing, just put 2 numbers together, just return, instead of returning 1 number, I want to return 2 numbers. Come on.
Wait, is it? Oh, tuple.
Yeah, this is list. This is
Tuple.
okay. What's tuple?
It's immutable.
Immutable what?
Tuple immutable.
Immutable what?
Doesn't change.
Immutable this.
change.
Yeah, well done. Can't change. Okay. So look,
Whoa.
if we return 2 numbers, the first one is the sum, the second one is the count, right? Does it make sense? If it's empty, we return nothing. There's no vertex. There's no node. Okay. Okay. So in order to calculate the sum of the sum and the count, for this function, we want to return 2 things. One is the sum. One is the sum. The other one is the count, right? So look, if this is the root, and if I have some tree here, I don't care. And I have some tree here, I don't care. Which is, this is root or left. And this is root or right. So how do we solve these 2 problems? How do we get a
Depth of search.
yeah, recursion, yeah. That's what we call. So first of all, we want to say sum left. And look, because it returns 2 numbers, and then the count left equals depth of search what? Come on, you just put.
Well,
What's this bit?
read or left.
Yeah, root or left, because we're calling itself. You have to return 2 values. And then you can tell me what's left? Sum what? Right, yeah? And then what? Count the right.
Right equals depth of search. Read or right.
Why? Okay, so now we have the sum of left and we have a sum of right. We have a count of left. We have count of right. Now, what's the if I put a max average here? If I have a max average here, at the beginning we set it to 0. So if we have max average here, and what's the sum? What's the sum of this binary tree? What's the sum of this binary tree? It will be what, s equals what? Sum left. Yeah, plus what? Plus what? Sum what? The tree will be the sum of the entire binary tree will be the sum left plus sum right plus what? Root of value, yeah? Plus root of value.
Value.
And what's the count? Total count. Count equals what? How many nodes are for this tree? Come on. Come on. You can get it. This is the sum, and I want to know the count, which is what? Come on. Count the left, and plus what?
Count.
This is count left. What's this?
Count right.
Yeah, count right. We already written here. Count left, yeah. And plus what? Plus what? Come on. This is the number of nodes in the left tree. This is the right number of nodes in the right tree. And how many nodes are here? Look.
1.
Yeah, plus 1. Okay. And now we have the sum. We have a count. So average, max average equals max of what? Two things. Max average equals two things. Max of what? We want to store the maximum of the average.
Sum.
S, right?
Counter.
Divided by C. And then what's this? What's the second parameter?
Max average.
Yeah, max average. Okay. And then we want to return what? As I said, the first one is what? A tuple. Return the first one is the sum, right? Which one is the sum? Return what?
Max average.
No. Return this. This is the sum. This is the count. So what do we return here? Come on. Which one is the sum? Which one is the sum? The sum of these whole three root. Which one is the sum? It's there.
Well.
It's there. Come on. Which one is the sum?
Count.
Which one is sum? S, look, sum. And what's the second parameter?
C.
C, easy, yeah? So look at,
Can you put them around?
no, because look, if you put them around, you need to swap these two, right? You see? Good point, yeah? Look, because step for search, you're calling Excel, then it will return two numbers. We are assuming the first one is the sum, the second one is the count. So that's why we put the sum left count. Sum left count. If I swap it, put the C and S. You put C and S, what should we change?
Sum left with count left and sum.
So we need to swap these two. Count left, sum left. Count right, sum right, right? Yeah, you see, this is returning the tuple, and I use this A, B equal. Look, what's the, remember this syntax? A dot B equals 2 and 3. So what's A? What's the value of A? What's the value of B?
2. A is 2 and B is 3.
Exactly, yeah, you see, exactly. What's the time complexity?
O n.
And what's the space complexity?
M.
Yeah, we're using the recursion, yeah, using the stack, okay. So now I'm going to erase.
Oh no!
Oh, I just return
Let me see.
Yeah, it's easy, yeah? It's easy.
Okay.
Okay, it's easy. I'm just going to erase these two lines, okay? Just, yeah.
Remember.
S and C, what's S and C?
Well, I don't.
Come on, the S, what's the sum of this root? It's there. What's the sum and what's the count? Come on.
S is
Left
plus right.
What? The
Sum left.
sum left plus
Sum right.
and then plus.
Root of value.
Okay.
And then counter.
And then count equals what?
Count left.
Plus.
Count right. Plus 1.
Yeah, we're done. Okay, you need to explain this, okay? Otherwise, you wouldn't compare.
What do you mean?
I'm just lazy. You know, I need to write sum left, sum right.
Why are you lazy?
Because I'm your daddy. Okay?
Oh.
Okay, that's it for today. Good job.
Bye 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 bye.
Bye bye. Bye bye.